Question 9b. When a valve is released, a chemical flows into a large tank that is initially empty. The volume, V litres, of chemical in the tank increases at the rate dV dt equals 2 times e to the power of t plus 2 times e to the power of negative t, where t is measured in hours from the time the valve is released. Part 1. At what rate does the chemical initially enter the tank? The term initial implies the value of dV dt at time t equals 0. So substituting t equals 0 into the equation for dV dt, we have dV dt is equal to 2 times e to the power of 0 plus 2 times e to the power of negative 0, and e to the power of 0 is equal to 1. So dV dt is equal to 2 times 1 plus 2 times 1, which equals 4. Therefore, the chemical initially enters the tank at a rate of 4 litres per hour. Part 2. Use integration to find an expression for V in terms of t. dV dt equals 2 times e to the power of t plus 2 times e to the power of negative t. Factorising out 2 from the right hand side, we get dV dt equals 2 times e to the power of t plus e to the power of negative t in brackets. Integrating both sides of this equation with respect to t, we get the integral of dV dt is equal to 2 times the integral of e to the power of t plus e to the power of negative t dt. Now the integral on the left hand side is equal to v, and the integral on the right hand side is equal to 2 times e to the power of t plus e to the power of negative t divided by the derivative of the index, which is negative 1, in brackets, plus the constant of integration c, which gives v equals 2 times e to the power of t minus e to the power of negative t in brackets plus c. Next, apply the boundary conditions to find the value of c. Now initially the tank is empty, hence the volume v equals 0 when t equals 0. So substituting 0 for v and 0 for t in the equation, we get 0 equals 2 times e to the power of 0 minus e to the power of negative 0 plus c. Now e to the power of 0 and e to the power of negative 0 is just equal to 1, and 1 minus 1 is 0. So 0 is equal to 0 plus c, therefore c equals 0. Therefore v equals 2 times e to the power of t minus e to the power of negative t in brackets. Part 3. Show that 2e to the power of 2t minus 3e to the power of t minus 2 equals 0 when v equals 3. Substitute v equals 3 into the equation from part 2. So we have 3 equals 2 times e to the power of t minus e to the power of negative t in brackets. The next step is to expand the brackets on the right hand side. So we get 3 equals 2 times e to the power of t minus 2 times e to the power of negative t. Next, multiply all three terms by e to the power of t. So we get 3e to the power of t equals 2e to the power of t times e to the power of t minus 2e to the power of negative t times e to the power of t. Now we're multiplying two terms with the same base, so we add the indices in this case here and this case here. So t plus t is 2t and negative t plus t is 0. So the equation becomes 3e to the power of t equals 2e to the power of 2t minus 2 times e to the power of 0, and e to the power of 0 is 1. So we have 3e to the power of t equals 2e to the power of 2t minus 2. Subtracting 3e to the power of t from both sides of the equation, we get 0 equals 2e to the power of 2t minus 2 minus 3e to the power of t, which becomes 2e to the power of 2t minus 3e to the power of t minus 2 equals 0 as required. Part 4. Find t to the nearest minute when v equals 3. From part 3, solve as a reducible quadratic equation 2e to the power of 2t minus 3e to the power of t minus 2 equals 0 by letting x equal e to the power of t. Expressing the left-hand side of this equation in terms of x, we get the non-monic quadratic equation 2x squared minus 3x minus 2 equals 0, which can be solved by applying the quadratic formula or by factorising. Factorising the left-hand side, we get 2x plus 1 in brackets times x minus 2 in brackets equals 0. And we need to discard the factor 2x plus 1 since x must be greater than 0 since e to the power of t is greater than 0 for all real values of t. Hence, the solution to this non-monic quadratic equation in terms of x is x equals 2. Now, substituting x equals 2 into this equation here, x equals e to the power of t, and solving for t, we get 2 equals e to the power of t. Rearranging this equation to make e to the power of t the subject, we get e to the power of t equals 2. Taking the natural logarithm of both sides to make t the subject, we get t equals ln of 2 or log base e of 2 hours. As a decimal, that's 0.6931471,806 hours, which equals 41 minutes and 35.33 seconds, which rounds to 42 minutes correct to the nearest minute.